Hi class, today we're going to look at another technique for factoring called completing the square. And completing the square is one of the tricky techniques which kind of sneaks up on you whenever you least expect it. So it is tough, it's a little bit challenging, but once you get it, it's one of the techniques that you can use if the AC method doesn't help you factor. Okay, so the best way to do it is by example so you can see the different features of how you complete the square. But the idea behind completing the square is that you have this polynomial and you are trying to get the first two terms. Let me use a different color. You're trying to get the first two terms to be a perfect square. All right, meaning that you're trying to get it to look like something like this. All right, either a plus or minus b. All right, a perfect square. So we are going to deploy this technique. I'm going to take, so as you notice, the polynomial that I have over here, which is x squared plus 4x minus 7, is similar to our generic definition, ax squared plus bx plus c. So what I'm going to do is I'm going to take the coefficient of the middle term, 4, and divide it by 2. All right, so I'm doing b divided by 2. And whatever the outcome that I get, I am going to square it. All right, so like I said earlier, I'm trying to make the first two terms a perfect square. So to do that, that means that it's missing a third term. So I'm going to write this out as x squared plus 4x plus a certain number that if I put in there will make it a perfect square. And then I do have my plus 7 and minus 7 on the side. So by doing this b over 2 and squaring it, I get this new number here. And that is what is going to go here. So I get the plus 4, but I have introduced a new number into the original expression, meaning that I have changed the expression. So in order not to change the expression, I need to compensate by adding the opposite of what I introduced into the expression. So I added a plus 4 into the expression. So I'm going to subtract a minus 4 so that if you added everything back, the plus 4 and the minus 4 cancels out. You still maintain the integrity of that polynomial. So I have made whatever is in the parentheses a perfect square, meaning that this x will come and fill in here, x, and whatever that I squared, so I squared a 2, so a plus 2 joins in here, and then that becomes a 2 minus 11. So at this point, I have put myself in a good position to be able to factor because I'm seeing two terms, a squared minus b squared, meaning that's a difference of squares. And I know how to solve a difference of squares. It's always a plus b, a minus b. However, when you look at this difference of squares, it doesn't stand out to you as a regular difference of squares because 11 is not perfect. But if you've done some radicals before, we can write this as x plus 2 squared minus square root of 11 squared. So indeed, it is a difference of squares. And the result is, if this is A and this is B, then I'm getting x plus 2 minus 11 and x plus 2 plus root 11. So that is the factored expression when you have that polynomial. And the process that I went through is what we're calling completing the square. So again, your job is to try and get the first two terms to be a perfect square. And you do that by taking the middle, the second term's coefficient, and divide it by 2, and then you square it. Whatever outcome you get is what you're going to add and subtract to both ends of the expression. Well, that turns itself into a difference of squares, and then from there you are able to do it. All right, so I kind of went through the explanation. Let's see if we can do the same for the next problem. All right, so again, I'm trying to get this to be perfect. So I'm saying x squared plus 3x plus something minus 4. All right. So one thing that we also like to consider is that for the completing the square technique to work, the leading coefficient has to be 1. If it is 1, you can proceed with the technique. If it's not 1, you'd have to clean it up a little bit for it to return to 1, the leading coefficient to return to 1, so that you can be able to do completing the square. So let's go ahead and do this example over here. So I first check the leading coefficient, which is 1. So I'm feeling good about doing completing the square. Now I'm going to take the second term and pick out its coefficient. So b over here is 3. I'm going to divide that by 2. So I end up with 9 over 4 when I square it. So let me write it out. So I get that, and when you do 3, when you do 3 over 2 squared, you get 9 over 4. So when I took the b and I divided it by 2, I ended up getting 9 over 4. That's what I'm going to introduce into the expression above. So I'm going to add a plus 9 over 4. But because I've introduced a plus 9 over 4, I need to counter that or compensate by subtracting a 9 over 4. Well, by doing so, whatever is inside the parentheses is a perfect square, which comes from x and then whatever that was squared. So this was a plus 3 over 2. And then what I'm left here is 25 over 4. Now, when I look at these two terms, again, it's looking like a difference of squares. So if you think about it, this seems like an a squared minus b squared. So it is a difference of squares, and I know how to solve a difference of squares. This is going to be x plus 3 over 2 minus 5 over 2. And then I get x plus 3 over 2 plus 5 over 2. Well, we can simplify this. This gives me x. That's negative 2, so x minus 1. And then that gives me 8x plus 4. And you can check it by expanding back. So x squared plus 4x minus 3 minus 1x is 3x minus 4. So it checks out. Okay. Let's look at the third example. So in the third example, I have negative x squared plus 4x plus 9. Like I said earlier, you need to check to see if the leading coefficient is 1. In this case, it's not 1. So there's a couple of things that we could do. All right. So I could divide everything by -1. So then now this expression looks like x squared minus 4x minus 9. So now this expression's leading coefficient is 1. I'm feeling pretty good about myself using the completing the square technique. So again, I'm trying to get the first two terms to be a perfect square. So I'm saying x squared minus 4x plus something, and then I'm left with minus 9. Now I have my b term, my b coefficient number is minus 4. I'm going to divide by 2. I get -2. Well, if I square that, I get what? I get positive 4. So I'm going to add a positive 4 over here. And because I'm adding a plus 4, I need to compensate by adding a minus what? A minus 4. Okay. So now, whatever is inside the parentheses is a perfect trinomial. It's coming from that x, and then whatever that I squared comes right back in here. So -2 all squared. I made a little mistake over there. That's supposed to be -13. Oh, sorry, that's something else. That's 4. So minus what? -13 is over here. Okay. So now my claim again is this is a difference of squares. This is the a squared minus b squared. So you can think about b being what? The square root of 13. All right, that was squared minus x minus 2. That was squared. So you can clearly see that it is a difference of squares. The solution is going to be x minus 2 minus root 13, x minus 2 plus root 13. Okay. All right, let's look at the next one. So this time around again, my coefficient is not 1, it's 3. So we got to find a way to get it back to 1. And I'm going to use a different technique. So in example 3, I divided everything by 1. So that I got that expression. In this example, I'm not going to divide by 1. But what I'm going to do, however, is I'm going to try and factor out the 3 so that it will become 1 for the leading coefficient from the first two terms. So again, I'm trying to do 3x squared minus 4x plus something minus 4. All right. So let me pull out the 3 out. So if I pull out the 3 out, I end up with x squared minus 4 over 3x plus something minus 4. Okay. So now my expression in the parentheses, the leading coefficient is 1. So I'm feeling good that I can apply the completing of square technique. So the b in this problem here is minus 4 over 3. I'm going to take that and divide it by 2, which gives me -4 over 3 times 1/2. That cancels out to give me -2 over 3. I'm going to square that so that I end up with 4 over 9. And so I have my 4 over 9. 4 over 9 is what I'm going to place into that space over there. And since I'm adding a 4 over 9, I'm going to subtract a 4 over 9. So there is a problem over here. Although I'm subtracting equal value, remember that I pulled out a 3. So I need to try and compensate correctly. So instead of just subtracting 4 over 9, it has to be 4 over 9 times 3. All right, so that's the other technique. Either you pull it out or you divide everything by that leading coefficient so that you can work the problem out. So now I have 3, and if I think about what goes here, the x goes here, and I squared negative 2/3, so that comes to join it, negative 2/3 minus, and then if I add this, I get 36. 36 minus 12 is minus 48 over 9. Okay. All right. Now my job is to try and solve this. So again, if you look at this, I should be able to clean this up nicely. This is going to be a little bit messy. So just bear with me for now. All right. So I'm going to get 3x minus 2 over 3 squared minus, that is the same as the square root of 48 over 3 squared. Okay, and then you can also see that that 3 is the same as square root squared. So for a complicated function like this or expression like this, the difference completing the square is going to be very messy. I'm getting square root of 3 minus square root of 48 over 3. And then you have square root of 3x minus 2/3 minus square root of 48 all over 3 plus. So that's as messy as it can get. Okay, you can clean this up to make it easier, but that's okay. You can leave it like that. Okay, because we can take the square root of 48, but that's fine. It's just exposing you to different things. Okay. All right, let's look at the last one. So the last one that I have, the leading term's coefficient is 1. So I'm feeling pretty comfortable doing completing the square. So I'm going to try and see that minus, plus what? Plus 3. And then I'm going to pick the b term, the b number, which is 14, and divided by 2, I get 7 over 7. And then I'm going to square it. I get what? 49. So I'm going to add plus 49 and minus 49. Okay. And now we're saying that whatever is inside the parentheses is a perfect square. So we end up with x plus 7 squared minus 46. Now this is a perfect trinomial, or a perfect, it's a difference of squares, meaning that this is x plus 7 minus root 46, x plus 7 plus root 46. So hopefully you are getting comfortable with completing the square, right? Because we're going to use this in another form version, but learning how to factor using completing the square is is a good skill to have. And you find out that in some cases, using completing the square is a more expensive technique than using the AC method. So you get to choose which technique you are comfortable working with. But in some cases, you do not have any choice other than to use completing the square. All right. So that's it for this lesson. I hope I was clear enough to help you understand.